now I have the TGA format open. And one thing you'll notice is it is saved in grayscale and it's not in index mode. So if we modify and adjust the levels once again, also make sure if you are making this sort of modification that you are not moving the center point, the midpoint contrast, because you're basically going to throw off the depth, and it will be unrealistic compared to the 3D geometry. But one nice thing about the TGA format is the ability to make that modification if you are going to use this lower depth image, being able to make a modification with grayscale mode and not create that grain. So for the most part, it looks similar to the PNG we had in the index mode. The next format is EXR, which is also a 32-bit format. And if we just modify the levels like we did earlier, we're going to see basically the same as the HDR image. The only thing that changes is the format used to save the HDR, or the 32-bit image. Although one huge benefit of the EXR format as opposed to the HDR format is the file size. File size is about half, and that is working with RGB. So if we were to save this out of grayscale, it's going to reduce the file size even more. So if you're going to be working with HDR or 32-bit images, using EXR format is just a huge plus because of the file size being so much smaller. And now the last format we're going to take a look at, which by far is my favorite, is the TIFF format. If we open up the 8-bit, one thing we'll notice is it's basically going to be the same as the TGA format. It's going to look the same. It's already grayscale, which is just what we need, and we've got that 8-bit separation of detail from the vast amount of depth in the scene, plus the file size is a huge difference. Just going to go ahead and close that, and if we just take a look, the TGA file has a file size of 768K, and the 8-bit TIFF is 84K. Huge difference between those two formats, with basically the same result. But now, I'm going to open up the 16-bit TIFF file, and we'll just do the same modifications as we did with the other ones. Another thing to keep in mind is the auto will sometimes move in a little too close to the black and sometimes even the white zones, so you might need to pull it out a little bit more. That's really not going to impact the other images we had too much. But we can definitely see a lot more detail coming out in front by not really clipping it out too much, because sometimes it will go over. But here is the 16-bit TIFF, which is unfortunately not a great file size compared to some of the other formats, but considering how much depth we get within the image, a lot of times the 16-bit TIFF will look better than the HDR. So I'm going to go ahead and copy this over to the other image and just overlay it. You can take a look at the differences. Control A to select all, M first to use the marquee tool, then Control A, Control C to copy, and Control V to paste. Oh, that's the wrong layer. And we'll just rename that TIFF-16. And now we can see the difference between the HDR and the TIFF. Now, because I adjusted the levels a little different, one thing I need to do is just pull in that histogram a little, and we'll do the same for the HDR. Just taking a look at where our black levels are. And it looks like we may cut something out, pulling this in. Looks like we've got enough information. So now they're fairly close. But for the most part, the detail is basically the same. And the amount of information we can gain from the image, as I was saying before, in my opinion, I think that the TIFF ends up looking a little bit better. One area we can take a look at to really see this, if we take a look at the HDR, one thing you're seeing is a harsh contrast and separation between these two different levels. We're not really seeing a nice smooth transition. If we change it over to the TIFF, that's really because the amount of depth. So you can see a little more depth in the HDR because we have that extra level in there. But the 16-bit is definitely way better than the 8-bit and is very similar to the 32. So what I would highly suggest is using the 16-bit. So basically, when you're saving out from either the Multipass or direct image saving, the two options you want to go for are either TIFF 16-bit or the EXR format. Surprisingly enough, the EXR format is actually, in this case, a smaller file size. But working in 32-bit can restrict a lot of features of certain programs if it's not designed to be working with 32-bit. And since most outputs are not a 32-bit image, there's really no sense in even using one. And if we go back to basically the reasons why the images look the way they do, especially looking at the bitmap here, if we take a look at the histogram, just by using the levels tool, we can see a nice looking histogram. What we're seeing is the slices of the different depth levels, which is very minimal because the overall depth we have to the scene was quite large. So once we reduce that to be able to really work with the image and see it a little better within the range that we actually have in the scene, we just have very little information. The amount of passes for the depth is just very minimal. Yet once we look at the other formats, 16-bit and 32-bit, we see this very nice transition and a lot of different slices of depth throughout the scene. Now, to be able to really see the effects that this has, I just want to use these images to overlay really quick onto the color to just create fog. That's something fairly simple. We could also use the lens blur as well. So I have the color, and I can load that in. This is also a 16-bit color. I'm going to go ahead and just convert this over to 8. We're really not going to lose that much detail. And I'm going to select our TIFF image. And I'm going to set the blending mode just to, let's go ahead and use screen. And then we can adjust the opacity amount. And we can see we're basically filling the scene with fog. Now there's really no color here on this layer, so I'm going to go ahead and double click on the layer to open the layer style options, add a color overlay, and we'll set this to kind of a lightish blue. And we can set this to overlay in the color mode. And it looks like maybe that blend might be too much with that color. Maybe we can reduce the overall color amount just to give a nice hint of color. We could also switch to one of the other modes to overlay the color. Let's go ahead and do darken. That'll work a little bit better. And if we switch the blending mode to lighten, you start to see more of the flatter tone and that fog, rather than it just lightening the entire amount of vegetation. So there's a couple of different ways to do it. There's really a lot of different techniques. This is just using the direct ZDepth for fog, so it's fairly straightforward. So this would be with the TIFF 16-bit, and I'm also going to grab, I'm going to end up using something different than that bitmap. I do want to use, let's go ahead and grab that TGA file. And take a look at the difference. We can just right click, copy the layer style, and then paste it on the new one. So for the most part, for a simple effect like this with fog, we definitely have more detail with the 16-bit, but the 8-bit does do its job. And the more we reduce the opacity amount and the less of an effect we need on the other layer, the more we can use that 8-bit. But the 16-bit is going to end up giving us a much better look. So let's go ahead and also use this just to use the lens blur. So what I'm going to do is clear the layer style. M on the keyboard for the marquee tool, Control A to copy or to select all, Control C to copy it. You can also use the edit commands. You can go up to select and all, and then edit, copy, and paste. We're not going to paste it just yet. First, what I want to do is select the background layer, double click, make it into a layer. Down on the bottom there is a mask option in between the effects and also the adjustment options. So we're going to select mask, move over to the channels tab. If that's not showing, you can go to window, select channels. I'm going to turn on the mask, and what we can do is paste into the mask channel, go back over to layers, right click to disable the layer mask, and then click off of it to get rid of that red overlay. And now what we can do is go to filter, and I'm going to select blur and use the lens blur, which is automatically going to use the layer mask as the source. I know my text is a little difficult to read. Basically, this first slider is the blur focal distance, so we can adjust at what point we want the image to start blurring. So we can create a nice depth of field effect. And this is going to give us a really nice transition. Down here on the bottom we have the iris in this zone here. We can adjust the shape that we're using to blur the area, and then also adjust the radius and the amount of the overall blur. Really increase that to a large amount and you can see the differences. And I'm not really going to worry about the other options. We have the ability to make it a little brighter in the specular highlights area. I'm just going to tone that down. And depending on the type of ZDepth you're using, sometimes it goes the other direction. So if you need to invert, this will automatically flip the mask. So you can click on this invert. Go ahead and click OK. And now we can see that nice blur applied to the image. Now if I was to use the other image, go ahead and clear the layer style where we have a lot less depth. And one thing I want to do is just go into the history and I am going to delete that lens blur. And now we can go over to the channel and paste that 8-bit to replace it. And do the lens blur again. This time with the lower res image. And we're not going to see nearly as much detail as with the 16-bit. And for atmospheric effects and blurs, it's really important that you have that depth, because otherwise you're just going to end up with these huge slices. Now, this scene is large enough where we can get away with the 8-bit. I do want to really quickly show you an example of something a little more concentrated in a smaller area. Basically, if you were to take the camera and instead of having it positioned tilted up where we can see the horizon, if you were to just have a small section of the scene, and actually I'll just go ahead and do that. On the other image. So if we were modifying just this small area of the scene, we would see, and once again that's the wrong image, so I'm going to go back really quick, uncrop that. That bitmap is a really terrible example. Just use the TGA. And I'm going to go back and just crop that. So we're working with a smaller area. Basically, the render is going to look exactly the same. So we really don't have a way to control the Z-depth within view. So we can see the difference. So if we're working with something this small, that extra detail is just absolutely needed. Because otherwise we're working with a very small amount of slices where we have like 5 or 6 different zones that are really showing up, and only 4 really clearly showing up, as opposed to these much higher amounts of depth. So makes a big difference. And with all the vegetation in this scene, we really can't see every single step of the way, but if we were to look at this with a terrain, you would really see those rings and separations of layer depth. Depending on how much detail you need in the Z-depth, there are ways to define and create your own channel outputs. But first, we're going to take a look at how we would save out the images we need for the Z-depth to be usable, because there are a lot of different options for Multipass. So if we go to the render options of our scene, we have a G buffer and a Multipass. Now, there are some pretty large differences between the two. The main thing is, the G buffer is meant for compositing applications, if they support these formats. The formats are RLA and RPF format. What they will do is save out all of this channel information. Uh, One I think is the most important is velocity, because it's really one of the only ones that isn't available within the rest or within the multipass. Velocity will allow you to control motion blur uh, based on color information, with colors moving towards the direction that it's traveling. So if it was traveling towards the x-axis, it would be red; towards the green, it would be, or towards the y-axis, it would be green; up and down would be blue, z-axis. So that information is really, really helpful for basically using a compositing application to control the motion blur, which is a vector-based blur. Now, if you don't have access to uh, these file types, or an application that can read them, or even if you do, there's still a lot available within the multipass you can't get within the gbuffer. Gbuffer is a fairly universal method for compositing. But the other multipass options we have, if we take a look, there are quite a few. And the more we have in the scene, the more is going to show up for the different mask options, because there are a lot of different masks you can export for individual ecosystems, materials, objects, layers, really a lot of different ways to break it up. We can also see that we have a ZDepth within the extra components. And a similar option is the distance to camera plane. However, the distance to camera plane at the moment in version 7.5, at least the version I'm using right now, is not working correctly. And it is providing a fairly inaccurate result. I'll just go ahead and show you. Normally the distance to camera plane works out a little better because of the anti-aliasing. I'm just going to check ZDepth and also the distance to camera plane. Turn off the gbuffer. We're just going to render the multipass, and I am going to render this to screen final. I do want to just do this really quickly, so I'm going to clear out the ecosystem, select the terrain, and clear. And now we can go ahead and render this out. So now if we take a look at the primary ZDepth, you can really see the slices showing up when you just have a terrain. And keeping in mind too that the preview you see in view is the 8-bit preview. It is not the 32-bit or 16-bit preview. So that is very important to keep in mind. Sometimes with atmospheres, it may look extremely grainy and look terrible, but if you were to save it as an HDR or a 16-bit image, it ends up looking a lot better. But now we can take a look at these gbuffer, or the multipass channels. ZDepth being the same as the main ZDepth output, which is always calculated. And in this case, it looks like the distance to camera plane is showing up, for the most part, correctly. There is one issue up at the top where you can see this line around the rim of the terrain. And when you output this and save it, especially in Photoshop format, it does look different, and will often be just so distorted you can't use it. It becomes based on color level, at least in version 7.5, and is not necessarily usable. So our saving options are broken up somewhat. If we go back to edit the multipass options, what we can do is either save separate files for every single pass. So anything that's checked within the multipass buffer will be saved out. We can see by default, just an example, it's showing shadow pass A, because one of the Options is the ability to save out the shadows. So we'll save the formats like that, and then you can choose which file type you'd like to use. And I just have my view temporary directory up here with some current files I have. But basically we can go through and there's a lot of available options. You could use any of the available formats for the Multipass. Another option is to save as a multi-layered Photoshop file. So PSD, and then what it'll do is take all of the layers, stack them in one file, and then all of the masks will be part of the channels. So now we can see with some of those masks selected, we can see we have 7 channels and 2 layers. So if I was to save this out and render it, and keep in mind it will save after you're done rendering, you will then have a Photoshop file you can use with a layer for every single pass and channels for every mask. Now, since we need to use a 16-bit image, we wouldn't necessarily want every single file if we were to separate the files. Since the Photoshop file will be 8-bit, you can't control the depth. It will just save as a normal Photoshop file, 8-bit. So if we need the 16-bit depth, we would have to save separate files as a 16-bit TIFF. But there is another way where we don't have to use the multipass to save out that Z, since we need such a high amount of depth for it, and we wouldn't want every single layer because the file sizes would just be huge. So one option we have is when we render to disk. And with render to disk selected, what we can do is select the options, and now you can define the format for the color, for the alpha, and also the depth, which is the Z. So you would want your depth map, the ZDepth, to be either the 16-bit TIFF or the EXR format. If you're used to working with other formats, then you can select those, but for the most part, you really need at least 16 to 32-bit to work with a proper ZDepth. So having this separation is extremely important and really, really helpful.